The engine moving components are the following: the pistons and their rings, the connecting rods and their bearing shells, the crankshaft, the camshafts, the valves, the timing and the valve timing components dephaser, and on certain engines, the balancer shafts. Move your mouse over the components to identify them. The role of the piston is to compress the gases by longitudinal movement inside the cylinder. The piston is composed of the following components: a cylindrical-shaped head with a diameter slightly less than the diameter of the cylinder, a skirt which guides it inside the cylinder, a gudgeon pin which provides the link with the connecting rod. The piston is moulded sometimes in cast iron, but usually of light alloy. To improve engine performance, the pistons may have several configurations. The piston has three types of piston ring, which are circular rings made of soft cast iron, sometimes steel, with a split groove which gives them a certain amount of elasticity. The fire-protective piston ring prevents the passage of flames towards the oil sump. The sealing ring maintains the gas compression. And the oil scraper piston ring prevents oil from flowing into the combustion chambers. The connecting rod transmits the force on the piston to the crankshaft. The connecting rod converts the piston longitudinal movement into the crankshaft rotary movement. The connecting rod, made of very high-resistance forged steel, comprises the following components: a small end joined to the piston via the gudgeon pin, and a big end which rotates around the crankshaft and consists of a removable big end bearing cap. The two removable sections of the big end bearing are fitted with steel anti-friction main bearing shells which are highly resistant to wear. The crankshaft transmits the mechanical energy to the valve timing and to the transmission. The crankshaft is a shaft made of cast iron or forged steel which rotates inside the bearings fixed to the lower section of the cylinder block. Click on each crankshaft component to find out its characteristics. The crank pins link the bearings to the crankshaft and are subjected to a special mechanical treatment to prolong their lifespan. The main bearing journals act as a guide during the rotation. The shaft, supported by the main bearing journals, makes up the line of the crankshaft. The main bearing journals are also subjected to mechanical treatment. The drillings lubricate the crank pin bearings and the main bearing journals. The camshaft is a shaft comprising the following components: projections made of treated steel called cams, and some bearings that have been subjected to mechanical treatment to prolong their lifespan. The camshaft is usually fitted on the cylinder head, and sometimes it is fitted on the rocker cover. The camshaft controls the opening and closing of the valves. The crankshaft drives the cams in a rotary movement via the valve timing components. If there are two camshafts, the first controls the inlet valves and the second controls the exhaust valves. The opening and closing of the valves is synchronized to the movement of the crankshaft. This is the valve timing setting. Move your mouse over the components to identify them. An identification number is engraved on the camshaft. The first three characters indicate the engine type. The next character distinguishes the inlet camshaft, A, from the exhaust camshaft, E. The last few characters are used by the manufacturer. Let's look now at the valve controls. There are different types of valve controls. Single rocker arms with pads, single or double rocker arms with wheels, tappet with shims, and monoblock tappets. Move your mouse over the components to identify them. The valves are located on the cylinder head and open and close the inlet or exhaust ducts. There are two types of valve. Inlet valves, which allow the gases to enter the cylinder, and exhaust valves, which control the evacuation of the burnt gases. The spring keeps the valve on its seat when there is no force from the camshaft. The seal between the valve and its seat must be perfect. The balancer shafts reduce engine acyclism generated by the forces caused by the combustion. The balancer shafts turn twice as fast as the crankshaft, as there are 2 returns to top dead center per crankshaft turn. The balancer shafts mainly comprise the following components: 2 balancing weights, a drive wheel, and a balancer housing. Move your mouse over the components to identify them. Here are some exercises to do before we continue. What is the name of each of these components? What is the role of each component? In this section, we covered the following points. The moving components are the pistons, the connecting rods, the crankshaft, the camshafts, the valves, the valve timing components, and the balancer shafts. The role of the piston is to compress the gases by longitudinal movement inside the cylinder. The connecting rod transmits the force on the piston to the crankshaft. The crankshaft comprises the crank pins, the main bearing journals, and drillings which lubricate the bearings. The camshaft is a shaft comprised of projections called cams, which control the opening and closing of the valves. An identification number is engraved on the camshaft. There are different types of valve controls: single rocker arms with pads, single or double rocker arms with wheels, tappets with shims, and monoblock tappets. The balancer shafts reduce engine acyclism. This lesson